Here, we'll convert moles to grams for this molecule. We have 10.2 moles of ethane, C2H6. Previously, we've used the equation that moles is equal to grams over molar mass. Now, this time we know our moles. We're trying to find grams. And to get there, we'll have to get molar mass. We can do a little bit of algebra to solve for grams. If we multiply both sides of this equation by molar mass, we'll end up with this. Moles times molar mass is equal to grams. Again, we know our moles, and we have enough information to get molar mass because we have the formula C2H6. So step 1 will be to find molar mass. For carbon, we have 2, and for hydrogen, we have 6. On the periodic table, carbon is 12.01 grams per mole. Hydrogen is 1.01 grams per mole. Now we multiply 2 times 12.01 to get 24.02. For hydrogen, we multiply 6 times 1.01 to get 6.06. We add them together, and we get 30.08 grams per mole. This will go in the molar mass position. Now we place our moles, 10.2, and multiply by 30.08. Our answer will be 306.8. This will be in grams. Now, let's look at our significant figures. Our moles are 3 significant figures. Our molar mass was 4 significant figures. We use the lower number of significant figures in our answer, that's 3. And so we'll draw a mark after the third significant figure. Now, since the number after the mark is an 8, we round up, and our final answer will be 307 grams. In this problem, we have 0.1488 grams of phosphoric acid. Our first duty is to convert this to moles, and then find the moles of hydrogen, the moles of phosphorus, and the moles of oxygen. First, let's recall that to find moles, we need to take grams over molar mass, or mm. Let's calculate the molar mass now. First, let's look to hydrogen. We have 3 hydrogens. For phosphorus, we have 1, and for oxygen, we have 4. Now we look up their molar masses in the periodic table. The molar mass of hydrogen is 1.01. The molar mass of phosphorus is 30.97. And the molar mass of oxygen is 16.00. We enter those now. For hydrogen, we have 3 times 1.01. For phosphorus, 1 times 30.97. And for oxygen, 4 times 16.00. If we take 3 times 1.01, we have 3.03. For phosphorus, we have 30.97. And for oxygen, we have 4 times 16, or 64. If we add all of these together, we'll have 98.00 grams per mole. Now, let's use this to find our moles. Our grams were given to us as 0.1488. Our moles are 98 grams per mole. Now, we do the division. We'll end up with 0.001518 moles of H3PO4. Now, to find our moles of H, we'll take the moles of the molecule, which is 0.001518, multiplied by the number next to H. That's 3. To find the moles of phosphorus, we'll again take 0.001518 and multiply it by the number next to phosphorus. Since phosphorus has no number, we use 1. Then, for our moles of oxygen, we'll take the same number, 0.001518, and multiply it by the number next to oxygen. That's 4. And then we'll go to a calculator to multiply these numbers together. For hydrogen, if we multiply 0.001518 times 3, we get 0.004555 moles of H. For phosphorus, we'll simply get 0.001518 back. And for oxygen, if we multiply by 4, we'll get 0.006073 moles of oxygen. And so now we found the moles of the molecule and the moles of each type of atom.